If the first acts of this story were an attempt to grasp the foundations of the system, its most obvious centers of gravity, the points that dominate both media narratives and strategic analysis, then we are now deliberately shifting the perspective, moving away from the largest and most recognizable oil fields toward a space that is less spectacular, yet far more complex, because it is precisely there that the logic is hidden, which allows the entire system to function not only under conditions of stability, but above all in moments of tension. For the real strength of the Persian Gulf does not arise solely from the existence of a few giants such as Gawar or Burgan, but from the fact that around them there exists a dense network of fields, installations, and connections that together form a structure capable of adaptation, and it is precisely the capacity for adaptation that determines whether a system can survive in a world in which volatility is the only constant. In the next acts, then, we will stop looking at the map in a linear way, as a collection of points marking places of extraction, and begin instead to see it as a structure of interconnections in which every oil field is at once a source of raw material and a component of a wider network, and in which its significance arises not only from the amount of oil it produces, but from the role it plays in maintaining the continuity of the flows that power the global economy. It is precisely here that something appears which may be described as the second level of the energy system, a level less visible yet more dynamic, because it includes medium-sized fields, deposits developed in stages, supporting installations, and structures that do not attract public attention and yet in critical moments become essential to the preservation of equilibrium. In practical terms, this means that when the largest fields begin to operate at the edge of their capacity or become exposed to disruption, it is precisely these less obvious elements of the system that absorb part of the burden, compensating for shortages and stabilizing flows, which means that their importance is inversely proportional to their visibility. At the same time, however, this network is not homogeneous because each of these fields operates in a different geological, technological, and political context, which means that their role within the system is not fixed, but changes depending on conditions, and this in turn makes the whole resemble a dynamic arrangement far more than a static structure. As we enter this part of the story, we begin to see that the global energy system resembles an organism more than a machine because it responds to stimuli, adjusts the way it functions, and makes use of different elements depending on the situation, which means that its stability arises not from immobility, but from a constant ability to transform itself. But with that capacity, there also comes a new level of risk, because a greater number of elements means a greater number of potential points of failure. And the more complex the system becomes, the harder it is to predict the consequences of a single disruption, which means that managing such a structure requires not only resources, but precise coordination and the ability to react quickly. It is precisely in this space between stability and uncertainty that most of the processes are played out, which determine the functioning of the oil market, because it is not spectacular events, but daily decisions, often invisible, concerning production, transport, and distribution, that shape the reality in which energy must continue to flow without interruption. At the same time, the global context in which this system operates is also changing because growing pressure for energy transition, the development of new technologies, and shifting political priorities mean that oil fields, even the smaller ones, are becoming elements of a game with much broader significance, in which what is at stake is no longer only access to raw material, but also the pace and direction of change across the energy system as a whole. It is worth viewing this part of the episode, then, not as a supplement to the earlier acts, but as their expansion, because it is precisely here that the full complexity of the system becomes visible, a system that on the one hand rests on several key pillars, and on the other on a dispersed network of elements which together form a structure capable of functioning in a world full of tension. Because if the first part was a story about the concentration of power, about points that dominate the system, then this part is a story about the distribution of that power, about the way it is spread, managed, and used in practice, which allows us to understand why the Persian Gulf remains one of the most important regions in the world, even though its structure is far more complex than it may first appear. And that is precisely why the next acts will not be merely descriptions of specific fields, but an attempt to read the logic of a system that operates on many levels at once, from local operational decisions to global strategy, which means that its analysis requires a perspective capable of bringing geology, technology, economics, and politics into one coherent narrative. This is the moment in which the story accelerates, though not in a spectacular way, but subtly, through the accumulation of small changes that together create a new quality, and we begin to see not only what is obvious, but also what until now has remained hidden, even though in reality it determines how the energetic heart of the Persian Gulf truly functions. If the fields we analyzed earlier were symbols of stability, birth, and expansion within the system, then Rumaila in Iraq introduces into this story the element of tension, because it is one of those places where geology meets the history of conflict directly, and where energy infrastructure functions in the shadow of events that extend far beyond the logic of the market. Rumaila is not merely one of the largest oil fields in the world, but also a space in which local and global interests have intersected for decades, because its location in southern Iraq, near the border with Kuwait, means that from the beginning it was part of a wider political context, and not merely an economic project. It was precisely this field that became one of the flashpoints that preceded the conflict at the beginning of the 1990s, when disputes over resources and borders began to take on a strategic character, showing that oil, though often seen as a foundation of development, can just as easily become a source of tension and rivalry. At the same time, however, Rumaila is an example of the extraordinary capacity of the system to survive, because despite years of sanctions, conflict, and political instability, the field not only continued to function, but was rebuilt and expanded, becoming one of the key elements of the Iraqi economy and of the global oil market. From a geological point of view, Rumaila belongs among the most productive deposits in the region, which means that its production potential is immense, and that in turn means that its significance extends far beyond the borders of Iraq, because every change in its level of output affects the balance of supply across the wider system. It is precisely this combination, immense reserves and an unstable environment, that makes Rumaila one of the most paradoxical elements of the energy system, because on the one hand it is a source of enormous value, and on the other, a place that requires constant risk management, both at the operational level and at the political one. In practice, this means that the functioning of this field depends not only on technology or resources, but also on the ability to maintain a minimum level of stability that allows operations to continue under conditions that in many other regions would be regarded as too risky, which shows just how deeply the energy system is capable of adapting to difficult circumstances. At the same time, Rumaila is also an example of the growing role of international cooperation in the energy sector, because its development was made possible through the involvement of foreign companies that brought capital, technology, and know-how, which means that the field functions not only as an element of the Iraqi economy, but also as part of a global network of interdependence. Nor can one ignore the fact that Rumaila is located in a region especially sensitive to geopolitical tension, which means that its functioning is closely bound to the security situation, and every escalation of conflict can have a direct effect on its operations, making it one of the most closely watched points on the world's energy map. At the same time, however, the field demonstrates that even under conditions of instability, it is possible to preserve continuity of production, which testifies both to the resilience of the system and to its dependence on factors that are not always predictable, which means that any serious analysis of it must take into account both economic and political dimensions. Rumaila is therefore a place in which different worlds meet in the most literal sense, because it connects geology with politics, local interests with global strategy, and market stability with regional instability, which means that its significance extends far beyond oil production alone. Because if we look at this field not as a source of raw material, but as a space in which the tensions of the contemporary world take material form, we begin to see that it is one of the clearest examples of how deeply energy and geopolitics are inseparable from one another. And that is precisely why Rumaila is not merely another component of the system, but one of its tests, a place that reveals whether the global mechanism is capable of functioning under conditions that are far from ideal. And the answer to that question matters not only to Iraq, but to the entire world, which still rests on energy flowing from precisely such places. If Rumaila was a story of tension and survival under conditions of instability, then Zakum in the United Arab Emirates moves us into an entirely different reality, one in which oil becomes not merely a resource, but also a field for demonstrating technological precision, planning, and long-term strategy, because it is here that the energy system reaches a level of integration that resembles advanced industrial infrastructure more than a classic oil field. Zakum, divided into Upper Zakum and Lower Zakum, is one of the largest offshore fields in the world, but its importance does not arise solely from the scale of its reserves, but from the way it has been designed and managed, because exploitation of this deposit relies on technology that makes it possible to extract oil with maximum efficiency, while at the same time limiting environmental interference and optimizing operational cost. It is precisely here that one of the most characteristic elements of the contemporary energy industry appears. Artificial islands created in order to allow operations to be conducted in a way more stable and more efficient than traditional offshore platforms would permit, which shows that the boundary between nature and infrastructure is beginning to blur. Thanks to these solutions, Zakum is no longer merely an extraction field, but a system designed in almost modular fashion, in which every element, from the wells to transport, forms part of a greater whole, and whose functioning depends on precise coordination and constant monitoring, allowing it to achieve a level of efficiency that would have been difficult to imagine only a few decades ago. At the same time, Zakum shows that the future of oil no longer lies only in discovering new deposits, but in maximizing the potential of those that already exist, which means that technological innovation becomes as important as the resources themselves, and in some cases, even more important. Unlike fields operating in conditions of instability, Zakum functions in an environment favorable to long-term planning, which means that its development can be carried out in a systematic way with future needs and possible market shifts taken into account, making it one of the most predictable elements of the system. At the same time, however, that predictability does not eliminate challenge, because offshore operations always carry technical and environmental risk, which means that maintaining a high level of safety requires constant refinement of technology and procedure, and every breakdown can carry consequences extending beyond production itself. Zakum is also an example of the growing role of international cooperation in the energy sector, because its development relies on partnerships between local and global firms, which means that the field functions as part of a wider network in which knowledge, capital, and technology move between different actors. Nor can one overlook the fact that Zakum plays an important role in the economic strategy of the United Arab Emirates, because the revenues generated by this field form the basis for investment in other sectors, which means that oil is being used here not merely as a source of income, but as an instrument of broader economic transformation. It is precisely that capacity to use resources strategically that distinguishes Zakum from many other fields, because it shows that oil can serve not only as the basis for present activity, but also as a means of constructing the future, which means that its significance extends beyond the energy sector itself. Because if we look at Zakum not as an oil field, but as a technological and strategic project, we begin to see that it is one of the most advanced examples of the way the contemporary energy system is evolving, moving from simple extraction toward complex and integrated structures. And that is precisely why Zakum is not merely another element of this story, but a sign of where the story is heading, an indication of the direction in which the oil industry is moving, toward a future in which technology, efficiency, and strategy begin to matter as much as the resources themselves, and perhaps in time even more. If Zakum showed how technology can transform an oil field into a precisely managed system, then North Field in Qatar and its Iranian counterpart, South Pars, introduce into this story an entirely new dimension, because here we are dealing not merely with one of the largest natural gas deposits in the world, but with a space that literally crosses state borders, creating a shared resource divided between two countries with different interests, different strategies, and different geopolitical positions. This field does not function according to the classic logic of sovereignty, because its geological structure does not respect political borders, which means that both Qatar and Iran exploit different parts of the same deposit, and the decisions taken by each have a direct effect on the other, regardless of whether their relationship is one of formal cooperation or underlying rivalry. In that sense, Northfield and South Pars form one of the most unique elements of the global energy system, because they show that natural resources can create forms of interdependence that extend beyond traditional state structures, compelling actors to function within a shared space of mutual dependence even when their political relations are tense. At the same time, however, this field is also an example of immense economic potential, because its gas reserves have allowed Qatar to transform itself into one of the most important exporters of liquefied natural gas in the world, which means that energy ceased to be merely a regional commodity and became part of global supply chains, reaching Europe, Asia, and other parts of the world. It is precisely for that reason that this field plays a key role in the transformation of the energy market, because natural gas, often seen as a transitional fuel, becomes a bridge between traditional sources of energy and renewable ones, which means that its importance grows not only in economic terms but in environmental and strategic terms as well. Yet what makes Northfield and South Pars especially interesting is the fact that its development unfolds within two very different political and economic systems, because Qatar, operating in conditions of relative stability and openness to international cooperation, has developed its part of the field rapidly and in close integration with the global market, while Iran, constrained by sanctions and functioning in a more restricted environment, has had to rely on different strategies, which has produced asymmetry in the use of the very same resource. That asymmetry shows that natural resources in themselves do not determine success, because conditions of politics, access to technology, and the ability to integrate with the global system matter just as much, which means that two states with access to the same deposit can nevertheless achieve very different outcomes. At the same time, however, this field creates a space in which competition and interdependence exist simultaneously, because the actions of one state affect the other, and the pace of extraction, investment, and export strategy become elements of a game in which there is no clear line separating cooperation from rivalry. Nor can one ignore the fact that the infrastructure tied to LNG exports, terminals, tankers, liquefaction installations introduces a new level of complexity into the system, because energy ceases to move only through pipelines and begins instead to function as a global commodity that can be redirected toward wherever it is most needed, which increases flexibility, but also dependence on logistics. In that context, Northfield and South Pars become not merely a gas field, but a node in a global energy network, a place in which local resources are transformed into global flows, which means that its significance extends far beyond the Persian Gulf. At the same time, however, its functioning remains closely tied to the geopolitical environment, because sanctions, regional tension, and shifting alliances affect the way in which the resources are used, which means that the field is not merely an element of the market, but an instrument of politics as well. Because if we look at Northfield and South Pars not as a gas deposit but as a space of interdependence, we begin to see that it is one of the clearest examples of how energy can both connect and divide at once, creating a system in which state borders lose their absolute character, and in which decisions taken on one side have a direct effect on the other. And that is precisely why this field is not merely another element of the story, but one of its turning points, the moment at which the energy system ceases to be viewed as a collection of separate resources and begins to be understood as a network of interconnections that define the contemporary world in both economic and political terms. When we place Rumaila, Zakum, and Northfield together with South Pars side by side, an image begins to emerge of a system no longer based on one single center of gravity, but operating instead as a multipolar structure in which different fields perform different, yet mutually reinforcing roles, together forming a system capable of functioning under conditions of uncertainty, tension, and constant change. Rumaila shows that energy does not exist in a vacuum, but always functions within a specific political and historical context that can either support its development or constrain it, which means that every oil field is at once an element of the market and a space in which the conflicts, interests, and strategies of states take material form. Zakum, by contrast, represents another model of system operation, one based on stability, technology, and long-term planning, where oil ceases to be merely a raw material and becomes part of a precisely designed infrastructure capable of maximizing efficiency and minimizing risk, showing that the future of the energy sector depends not only on resources, but on the way those resources are used. Northfield and South Pars, meanwhile, add to the picture a dimension of interdependence extending beyond the borders of individual states, showing that natural resources can create systems in which decisions taken by one actor have a direct effect on others, which means that energy becomes not merely a commodity, but an instrument of international relations. Together, these three cases create the image of a system that is at once differentiated and coherent because despite differences in geological, technological, and political conditions, all of them function within one shared logic, the logic of energy flow that must be maintained regardless of circumstances, which makes this one of the most complex mechanisms in the contemporary world. It is precisely this complexity that makes it impossible to analyze individual fields in isolation, because their significance becomes visible only when we see them as elements of a larger whole, within which every movement, every decision, and every disruption carries the potential to produce consequences extending beyond the local context. At the same time, however, this structure is not stable in the traditional sense, because its equilibrium rests on a constant process of adaptation to changing conditions, which means that it functions more like a dynamic network than a static construction, and its durability arises not from immobility, but from the ability to adjust. In this context, the concept of systemic resilience becomes especially important. Not as the absence of disruption, but as the ability to absorb and neutralize it, which in practice means that fields such as Rumaila, Zakum, or Northfield do not merely produce energy, but also function as buffers that make it possible to preserve continuity across the wider system. At the same time, however, each of these elements introduces its own specific risks into the system, because political instability, technological complexity, and international interdependence create conditions in which even small disruptions can lead to consequences out of proportion to their immediate scale, which means that managing such a system requires not only knowledge and resources, but also the capacity to anticipate scenarios that have not yet taken place. It is also worth noting that this part of the system shows clearly that energy is not merely a matter of economics, but also an instrument of power, because control over resources, technology, and infrastructure translates directly into the ability to influence other actors in the market, which is why oil and gas fields become one of the key components of the global strategic game. Because if we look at this structure as a whole, we begin to see that the world of energy has no single center, but many points which together form a balance of forces in which equilibrium results from interaction among different actors, rather than from the domination of any single one of them. And that is precisely why this part of the story matters so much, because it shows that the contemporary energy system no longer rests only on the largest and most obvious resources, but on a complex network of interconnections in which every element matters, and in which the significance of each is revealed most clearly in moments when the system itself is put to the test. This is the beginning of the next acts, in which that network will become even more visible, and we will begin to see not only its structure, but also the tensions that shape it, because it is within those tensions that the answer lies to the question of the future of the global energy system.